Hello and welcome to Geolytics. It's now August of 2023 and it's been 3 years since we released the platform in 2020. The original videos that I recorded back then are a little outdated. We've added so many new features, changed so much in the platform that we thought it was high time that we recorded a few new videos. Today we'll be looking at the use of Geolytics to map out utilities. Now, there's going to be a data set that we'll be working with for a few of these videos, and it just so happens that the same data set can be used to find utilities. There's some interesting geological features in there, so we can do a video on geological mapping and also on bridge deck analysis because the same data set happens to have some very nice rebar to map. So the data set comes to us today from Concrete GPR in Eugene, Oregon. So everything's going to be in feet, which is fine. We can do metric or imperial within Geolytics. So let's get into this. Geolytics itself is set up very much like a Windows desktop environment or a Mac environment where you have a root directory. And within that root directory, you have folders or directories, as you may call them. Now, I organize mine via sort of through geography. Other people might do it through client names or month of the year or by date or geographic location, whichever way you choose to organize your files. So I've created a new folder or directory called Concrete GPR Eugene, Oregon. And we're going to put all of their projects in one folder so I can organize them within the platform. If I double click on that, I go into an actual project. Now we can have folders within folders, just like in Windows. In this case, I've just placed a project within a folder. And a project file is very much, you can think of it like a Word document or an Excel spreadsheet. It is a single file, but it contains all your geophysical data, all your mapping, everything, interpretations is in one file. So this is, we call it Concrete GPR Demonstration Project Utilities. Let's go into it. Now, this type of project has no information around GPS. This is not a GPS project. I chose to demonstrate with a very basic traditional grid project because this is probably the most complicated to set up within a platform to give the platform information on where the profiles are. Now, to save us time, there's something like 81 profiles here. And to save us time, I've actually already uploaded quite a few of them. So here they are. There's profiles 10 through 89. I've saved the last two, which I'm going to upload. Now, these happen to be GSSI data sets, I think from a hyperstacking 350 megahertz antenna. I'm just going to take those last files and drag and drop them into my Geolytics window, and they're automatically uploaded and placed in the right location within the list of files. So here they are. That's great. Now, we have some field notes from the guys in the field, and this is a very bad sketch, but effectively what it tells us is there are lines in two directions. One's going left to right, so that's the X files, and one's going from the bottom to the top, which are the Y files. The X files go from file 10 through file 42, and the Y's go from 43 to 91. Okay, so let's create a folder called the X files. We'll just call it X for our cases. And I'm going to go in and take 10 through 42 and literally drag those files by holding my mouse button down to the X files. Next, I actually like saying that. The next one, we're going to create a new folder and we'll call that Y. And these are going to be the remainder of the files. Okay, so we're going to take those ones and drop them into the Y folder. All right, so now we have the X's and the Y's. Now we have to tell the platform how these things are spaced out, what the grid actually look like. Now, my notes show that the X files are spaced at 1 foot separation, Americans. And the Y files are at 2 feet separation. They got lazy, I guess. All right, so let's go to position and we'll see, here we go. We have the X and Y directories, and you could have multiple directories. In fact, if you had multiple grids in the same place, you'd have, X1, Y1, X2, Y2, and you can have multiple grids in different directions, different rotations for that matter. You can build up a very complex project structure all within one project file. In this case, we just have one grid. So let's go and take a look at the length mode. We have to declare what the station spacing, or so the trace spacing, I should say. And in this case, of course, it's embedded in the GSSI file, so we're going to believe that. We can add a compensation factor if we think our odometer is wrong by a few percent. Let's assume it's correct. Okay, we got that. Now, what else do we need to know? The origin is at 0, 0, that's fine. The profile separation, this is in feet, and we're going to go ahead and call it 1 foot. And we expect this to be at 90 degrees because these are going from left to right. So now we've got everything looking pretty good. However, if I look at that top file, I see its name is 010 file 10. But wait a minute, according to my little map here, that should be at the bottom. I've got these backwards. So I can easily change that by just clicking that button. And now everything's flipped around. And now that is indeed the file I want at the bottom of the screen. Let's do the same for the Y direction. In this case, yep, the angle is 0. The profile separation is in feet. And it's going to be 2 feet. And we'll tell it that the embedded trace separation is good enough. And here we go. We now know what the grid looks like. That makes a lot of sense. They've obviously had a little bit of issue here. One line didn't go to the end, but we have pretty good coverage. So that's great. Now, if we wanted to, we could add more information. We could add latitude and longitude and put a satellite background image. We can add other geophysical data sets. But let's just start off with this and start processing this. So there's 2 ways of processing within geolytics. We have a manual way, which I'm going to show you right now, where you manually enter each step in the processing flow, or there's an automated way that'll do all the processing for you based on a best analysis that the platform does of your data set. So let's go ahead and start processing. And to do that, we'll hit process and we'll simply add a new process. But before we do that, let's take a look at this actual file. Geez, there's really nothing there. I can see something, some light, but there's nothing there at all. So what's going on here? Well, that has to do with 16-bit and 32-bit interpretation within the platform. GSSI writes their data as 32 bits, but mostly uses about 16 bits, which means that there's everything clustered around the center of the spectrum, which means everything's gray. Well, you can't see anything, so we can easily fix that. In fact, there's a warning that comes up here saying, add a constant scale. Bang, we add that. Wow, everything looks great now. And in fact, when we look at this, we can easily see that we have a time zero correction that we need to make, but there's also the rebar on top. Now, we're interested in the much deeper pipes, so let's see what we can do around that. The first thing we want to do with any of our GPR data sets is fix the time zero correction. So we'll just go to add new process, time manipulation, time zero correction, and that'll do it automatically for us. The next thing we want to do is actually see some of this deeper stuff, right? So we want to add a gain. And the easiest gain that works most of the time is called an energy decay gain. And what you might want to do is just slide up this smoothing window to about halfway. Wow, there you go. So we can see everything we need to see on the data set right away. It's done. We've basically processed this. Well, we want to take it a few steps further, right? So the first thing we want to do with this now processed data set is kind of understand how fast the radar is traveling within that medium. And to do that, we have a tool here that'll just take a little hyperbola matching tool, and we can try and grab one. Well, that's about right. It's good enough. You don't have to get it exact. So now we have a depth scale. We don't just have travel time. We know how deep we are. So we can go ahead right away and start interpreting this. I mean, I can easily see that there's a pipe right there, but there's something about this data set that we can actually improve on a little bit. Do you see that there is a very slight horizontal banding there? That's not the geology. That's the geology up here. It probably is the slab on grade or something. That might be the base of a concrete. But the point is that's, let's say, geology. But this stuff's all horizontal, so we can get rid of that with what's called a background removal filter. We go to filters, background subtraction, and look, it's gone, right? This is pretty clear now. However, oops, look what I did. I might want to map out that geology, and I've kind of taken it away a little bit. So one way of bringing that back is to increase the trace window. And what we'll see is the geology comes back, but that horizontal banding is gone. And we can turn this on and off so you can see what that really looks like. See the improvement there? Now, these processes that I'm adding, you can flip them around or do whatever order you want. I'm just happen to be working in this order. All right, so here we go. We can see everything. Let's say we're interested in this big pipe right here. Let's just start interpreting. So what I'm going to do is close this section, and my layers are very much like a GIS application. If you're familiar with GIS, you can add a layer. So we're going to add a layer, and let's call it a point. And today we'll call our points, I don't know, green, I guess, a light green, and we'll make them triangles. And let's just go ahead and place one right at the apex of the hyperbola. Here's our first point. It turns up on the map. We can then click this next line and click it again. Now, one could argue where exactly should you put it, but for the purposes of the demonstration, you get the idea. Okay, so as we go along, we're adding points to this. Very easy way of doing this. But there's something else we can do. We can show, instead of the green points here, we can show it as a depth scale. So why is that important? Well, let's say I got a little sleepy and I messed up. I put a point down here. We can see it's supposed to be here, but I screwed up and went here. Okay, look what happens to the color. It turns red because it's in the wrong place. So that's a very quick check as you're going along. You can go, whoops, I made a mistake. I got to go back there. And what I can do is take my point and literally drag it to the right location, and it should turn a nice, okay, now they're all red, but at least they're all in the same place. So we're all lined up, everything's correct. That's one way of doing it. We can also look at this in 3D. So let's show this here. And actually what I'm going to do is take the bottom away. All right, so and I'm going to increase my vertical exaggeration so it's a little bit easier to see. And what I can do is start with these. It's actually Alt-2, or we can press this increase button. We can just go to the next profile. I think we've already done that one. Here we are. So now I can add my point again, like so. And I go Alt-2, I'll go to the next one, and so on and so on. So I'm literally chasing that pipe along, right? And I sometimes find it easier to do that. And we can see that we've got a pipe being created there with points. So let's actually create that pipe for you. Let's go to Add Layer, and this is going to be a polyline. Let's make it another green here, and let's give it a diameter of, I don't know, 20 centimeters. So we'll actually make it a cylinder, and we'll go ahead and create a new line here. So I'm going to try and line this up carefully. And it's just the angle that I'm doing it at looks a little funny, but this should line up perfectly. And what we're seeing, let me go back to the top view. There we go. We've got our pipe being made. So that's one way that we can do that. But boy, this could take a really long time because we've got 91 profiles to go through, and you saw that this was a complex site. So I'm going to hide that polyline right now. And this is just like a GIS application. You can put things in different order. We can have satellite information, you can have magnetometry data, whatever we want, but let's hide those. Let's go ahead and show you how we would do slicing. So being able to look at this really in 3D. We'll go back to our processes, and I'll just click that first profile again. Here's our original profiling. Now, we need to add 2 more steps for processing to do the slicing. The first one is migration, where we take that hyperbola and we collapse it down into a single blob, right? A black blob. And, oh, well, it's actually a white, black, white in this case. And then we want to do a Hilbert transform to take that waveform and do an envelope function and create a black blob. So let's go ahead and do that. I'm going to show you one trick here. So I'm going to go New Process, Filter, Migration. I'm going to use the project velocity. And here's one of the beautiful things of being able to do this in the cloud, how fast we can see this generate. So as we slide this along, we can control exactly how wide of a migration routine we use. And what we're trying to do is get those arms away and see if we can get it as tight as possible. Now, we don't want to go too far. And you can see what happened here to the rebar as well. They fine-tuned into a single point. So that's great. I'm pretty happy with that. That turns out to be about 25, 27 traces. However, I might want to go back and look at the original hyperbolas, right? I want to see both. So here's a neat trick. We're going to go here, processing tag, add new processing tag, slicing. I'm going to apply this only for slicing. And the next one I want is filters, Hilbert transform, and again, I want to do slicing. Now look what I can do. See these two tags here? I've got base processing, so here's my original hyperbola, and slicing, which is pretty cool. Okay, let's go back and do some slicing. All right, so here we're going to add a layer, slices. We've got lots of color schemes. You can create your own complicated color schemes. I always tell people to just use black and white. It's so much easier. It's easier on our eyes. The source we're going to use is the slicing processing. And now we have a tool here that automatically gives us the best parameters for this type of data set here. And then we're just going to go process. Now, this entire data set is about 350 megs, I think, something like that. So rather than relying on the 8 cores in my computer, we're able to spin up quite a few cores on servers that can parallelize the migration routine and all the processing. So what it's doing right now is doing all the processing and trying to create those slices as quickly as possible by distributing the workload amongst a bunch of different servers. And that's really the advantage of being able to use cloud processing. Oh, okay, well, we're done. So here we go. Okay, we're in black and white. I'm just going to close that. And so I can see now, wow, right at the top, we have two kind of weird oval shapes. I don't have a drone photo, otherwise that would be really interesting to see if there was something that was evident in the asphalt on top. But let's just start going down a little bit at a time here. We're going by 5 centimeters, and there's our rebar. Isn't that interesting, right? We can really see the rebar come through, and then we lose the rebar. Where's our pipes? Well, our pipe, wow. Okay, so, okay, well, the pipes are really, really easy to see. They're sitting at 80 centimeters, and I mean, that first one comes in a little earlier. So I can continue creating my polyline here. Well, I don't want to turn that one back on. I'm going to create a new polyline layer and maybe make this one, magenta, and we'll give it a thickness so we can see. All right, and I'm just going to go ahead and, well, I'll actually do this one here. So I'm going to draw that one out. As well, actually, does it go up or down there? You know, we could argue that it drops down a little bit there. Okay, something like that, right? And again, this is all, of course, 3D aware. So as we move the slider down, we can see that we've actually got a little bit of a dip in the pipe there. And that's how we would process and interpret. Let's go back to the top down. Interpret pipe data. Very, very simple to do, very straightforward. And of course, from here, we can take that information, our polylines or the entire model, let's say the polyline, and export it as a number of different file formats, as a CSV file with just the labels on it, or a DXF. And even the DXF, I know in the UK it's very important to have the depth labels, and we do actually export that. If this had been geo-referenced in the real world coordinates, we can export a KMZ file or a shape file. So that's what I wanted to show you as the basis for some of the improvements that we've made to geolytics. I look forward to making more videos in the coming while on other applications. Thank you very much.